Hey guys, welcome to today's video. In this video, we are going to solve one more Leetcode question, and the question is 94 binary tree in order traversal. So this is one of the traversal DFS traversal algorithm. Okay, and it comes under easy. Okay, let's understand this question. So here the question is, given the root of the binary tree, return the in order traversal of its node value. So the question is very simple. We need to do the in order traversal. Okay, so in order means you need to traverse the left side of the left side of the tree, and then you traverse the root, and then you traverse the right side of the tree. So let's see, let's understand it by example. So if you come over here, so this is your root. So we need to traverse left first. So left is empty, so we need to go to the root. So we traverse the root, so it is 1 is added over here. Now we have to traverse the right, so we come over here. Now we need to traverse, before traversing the root, we need to traverse its left. So we will traverse 3 first. So 3 is here because nothing is there after that. And then we traverse the root, which is 2, and then the right. And right, we don't have anything. So the output is 1, 3, 2. Okay. So now we can understand this. Let's come over here. Like I said, for in order traversal, we need to traverse the left side of the tree, then the root, and then the right side of the tree. So now we come over here. So this is our root, so we need to go to the left because we need to traverse the left first. So we came over here. Now this is also a node, so we need to traverse its left side. So we come over here. Now we need to traverse its left, but nothing is there, so we don't have anything, so we will traverse this. Okay, so now the 4 we got as an output. Okay, now we have traversed this. Now we need to traverse its root. So its root is 2, so we traverse it. Now this is also got traversed. Now we come to the right side of the tree, right? So in this right, we need to traverse its left. So 6 is the left, so we traverse it. Now the root, so root is 5, so we have traversed 5. Now to the right, so the right is 7, so we traverse this. Okay, so 7 is traversed. So if you see for this one, so all the left subtree has been traversed, right? Now we need to traverse the root, so which is 1. Okay, now we come to the right side. So for this right, we need to traverse its left, but nothing is there in the left, so it's fine. So now we traverse the root, which is 3, so we traversed it. Now we come to the, so left side of the tree is traversed, root is traversed. Now we came to the right side of the tree. Okay, now for right side of the tree, so we need to check its left side first. So in the left we have 9, so we need to traverse 9 first, which we did. Now we need to traverse the root, so that is 8, so we traverse this. And now to the right, so right, nothing is there, so we traversed all the thing. Okay, so this is how we do the in order traversal. We traverse the left side of the tree, then the root, and then the right side of the tree, and we need to do this recursively for each subtrees. Okay, so even though the explanation is little bit lengthy, but if you write the code in a recursive manner, it is 3 lines of code. So let's get into the coding. So if you come over here, so for the resultant, we need to create a array list. So we can create as a list. Okay, so now we need to do in order. We'll write this method where we will pass the root and this list. Okay, and after this we are going to return the list. So now we need to implement this method. Okay, so this will be a private method, and we'll return nothing for this. Okay, and what will be the input? So the input will be this root, okay, and this list. Let copy from here. Okay. So what we will do, first we will check if our root is null, then we can simply return. Okay, because it's a void, we can simply return. Now we need to traverse the left side of the tree, so we will do in order root dot left. Okay, and we need to pass the list also. Okay, so what this will do, so this will take you to the leftmost tree, okay, leftmost node. Okay, so you went to 1, then it came over here, then it calls the left. You went to 2, then it calls its left. You went to 4. Okay, now you went to 4, now you got the null, so which is this. Now you got the null, and there will be a return from here. Okay, so now nothing was there in the left, so you came over here. So when you are at the 4, so your 4 becomes the root. Okay, now you need to traverse the root. So for traversing it, what we are doing, either you print it. In our case, we need to add it to the list because our return type is list and not the printing of the data, right? So we add the data into the list, so we traverse the list. Now we go through the right, so in this right also it will be null, so 4 will get added. Root dot right, we'll pass the list. Okay, so this is the main, this 4 lines of code. Okay, so now let's run this. So our test cases got passed. Now let's try to submit it. So our test cases got passed, which is good. But now the main thing is that this is actually a very simple algorithm. But if you come over here, the follow-up is the recursive solution is trivial. Could you do it iteratively? So we need to mimic this piece of code in an iterative fashion. So now, what is the first thing it should come in our mind? Since we use recursion, so we take help of the call stack to write our code, right? So we need to mimic the call stack. So what better thing is there for mimicking the call stack? It's a stack itself. So we are going to use the stack data structure. So now what we are going to do, I'll just reverse this. So since our end result, we need a list, so we are going to create the list as before, which we are going to return. Okay, now for call stack, we are going to mimic call stack. So we are going to create call stack of 2 node. Okay, new stack. Okay, now to create the calling of the function again and again, so we are going to write a while loop where we are going to write root not equal to null, and actually it should be or till our stack is empty. Okay, so now this will call again and again. So till our stack is empty or our root is null. So this is our a kind of a base condition. So this base condition was similar to what we had earlier. Okay, if root was null, then we are returning. Right now, for like I said, for this Inorder traversal, we need to traverse the left node, then the root, and then the right side of the node. Right, so we need to go and access the left side of the root first. So to do that, to go to the left side of the node, what we are going to do, we are going to write one more loop where we are going to put the same condition where root is not null, and we are going to use a stack dot push root. Okay, so we are going to push the root. So when we traverse 1 2 4, so we are pushing in the stack. Why we are pushing in the stack? Because we don't have to read it now. Till we read the left side of the node, we don't have to read the root, right? So what we are going to do, root is equal to root dot left. So once we execute this, we reach over here. Okay, once our left side of this root, so suppose we came over here, now root is 1, we added 1 to the stack, and then we came to root dot left, which is 2. Now we again came over here, we add the root to the stack, which is 2. Now we came over here, which is 4, right? Now we are doing for 4 dot left, so which is null. right? So this route is null, so while this is null, it will come out. Okay, now we need to traverse this particular route because the left side is null. Now we need to traverse the 4 as a route. So what will be our route? Stack dot pop. So it is the last in first out, so 4 was the last node, so we are going to pop this one. Okay, now we are going to add in the list, okay, root dot val. And now since we came to the left, we traversed the route, now we need to traverse to the right, right? So what we are going to, so our route will become root dot right. So after all this, we are going to return the list. Okay, so let's try to run this. Let's try to submit with all the test cases. Yeah, so it got passed. So this question has been asked to me in many interviews, especially they say you don't have to do with the recursion, do it iteratively. So this is the code for that. So I want you to try the other two traversal algorithm as well. So considering the post order and the pre-order, you can try with yourself. If you want, I can create a video for that as well. Just let me know. Thank you.